Just as a quick recap of the last screencast, we looked at mechanical advantage and how you calculate it. And so the formula we had was MA is equal to F out, or the output force, over F in, the input force, what you put in. Okay, and just in case you didn't get a chance to do it, if the quality was quite low on your screen, hopefully you clicked on the actual video itself and you can watch it on full screen through YouTube. Okay, and you can also do the same with this video as well. Now, let me give you one of the examples we use there. Okay, so let's say, for example, you have some numbers here. Let's use gray. Now, let's say the output force is 52 newtons, and the input force you put in, let's say it's, keep the number simple, 5.2 newtons. Put the decimal there. And when you do that, when you perform the division, what you have is 10. Okay? And so this mechanical advantage, if you remember from the last post, is greater than 0. Okay, so let me draw an arrow here. So MA is greater than 0. Now what this means is what you get out of it, the output force, is much greater than what you put in. So this is a good situation. So what you get out is actually 10 times what you put in. That's great. Okay? So if you're in this situation, you are quite happy because you're getting a lot of result for less inputs. Now let's say, as another example, if you did some other calculations, if the mechanical advantage was less than 0, for whatever reason, say the mechanical advantage is 0.5, what that would mean is what you get out of it will actually be much less than what you put in. And if that is a situation, that is not as good because you're putting in a lot of effort but not getting as much out. So those are the rough indications of what mechanical advantage actually means. Now, I'm hoping you've had a chance to get your textbook, and if you have it in front of you, you should have it open to page 120. We're going to look at the lab that we will be conducting in your very next science class. So in this class, you'll get a few items. One of them is a retort stand. I'm just going to draw it from the side. So it's basically a stick and a metal stand. You're also going to get a clip. So this kind of attaches to the stand. Kind of looks a little bit like this. That's your clip there. Okay. And then you're also going to get a meter stick. Okay. So let me kind of draw it, hopefully in a little bit of 3D. So let's say you have this meter stick here. Okay. And let's say this, and then to the meter stick, you're going to use a little bit of string. You're going to attach a mass to it. Okay. Now, obviously, if you attach the mass to this end, it's going to be weighed down because there's nothing on this end here. So it's probably going to be dipping down when you first attach it. You're actually going to tie it on with some string. You're also going to tie the meter stick to the clip with a little bit of string. Okay? Let's do a little bit of labeling here. So we're clear. Retort stand. Over here is the mass. Over here is, I'm going to call it the clip. This thing here is the meter stick. Okay. Now, this is very important, very important. So what you're going to have here, let's use red, okay? Over here, the meter stick is going to start from here, so 0 centimeters. You are going to tie on the mass to the 5 centimeter mark. Okay, so make sure you have the meter stick in the right location. Now on the other end, okay, of the meter stick, at this mark here, you're actually going to tie on something you might have worked with before. Draw it very roughly here. Say spring scale. Okay? And in case you're not sure what it is, I'll definitely show you in class. Whoops. Write that spring scale. And the important part about this is you also need to tie this on at a certain location, so you get a little bit of string and some tape to lock it in place. You're going to tie it on at the 95 centimeter mark. Now, when this is set up, since there's a mass on this end, let me color it in black. This is going to be a lot heavier, so most likely the mass will unbalance it. So that means this mass will kind of weigh it down. Okay. Now, what you're going to do with the spring scale is you're going to take your hands, just draw a hand here, a very poor hand, and you're going to pull it down until this meter stick is balanced. So let's see, it's getting a little crowded here. Let's use green. Okay. So I'm going to draw a long arrow here. Pull down until, let's use this term, until meter stick is parallel to the ground. Okay. Another way of describing this, you kind of pull it down until the mass is perfectly balanced with what you're pulling down on. Okay. And then you'll take a measurement on the spring scale, and I'll be showing you how to do this during our lab, and you'll be recording your results in the table. Okay. So your homework or your task for this is very, very simple. Let's use black again. So homework number 1. Read page 120 in case you haven't already. Okay. Number 2, construct table. Okay. On page 120, and that's the only table on that page, just kind of do that in your notebook. And number 3, just to tie in the practice we've been doing, I want you to complete questions 1 to 3 on page 119. Okay? So some nice, easy homework for you focused on mechanical advantage.